Hello everyone, welcome back to the new podcast. So my name is Paras and this is my friend Rohan. He will be our guest for today's podcast, which topic is load balancing techniques.
Always happy to Paras. And today's topic is one of the geniusly love load balancing. It is one thing. The quickly make sure your apps don't fail over the thousand of the people so at once.
The stages. Why does load balancing actually needs to be exist and what are the problems in solving it?
Okay. Load balancing process is distributing incoming network traffic across multiple servers so that the single server become the it is the fundamental to build system that is are faster reliable and scalable. Think about the happiness when popular website gets with millions request per minutes one server can handle, but if you have a hundred servers and a load balancer in a form to them, each server only sends the hundred of the request per minute manageable.
So the client, say my browser, never knows it's talking to multiple servers.
Exactly, from your browser perspective, this is the one address or one IP or a domain, and you were sent request the load balancer intercept in a peak server, forward request, get a response and a sends. This is back to you. You never know. There is the 50 servers behind if that is the beauty of it.
So this is what the cloud services like Netflix and Instagram handle peak traffic without failing over.
Every single time in the during the major event, major blow, viral moment, product the launch, the traffic can speak the then I times normal value in a second without the load balancing. You need to server size for the peak setting mostly idea rest of the time when with load balancing. You have a flat that is scales with demand and balancers distributing the work intelligently.
So where does the load balancer itself sits itself in the network? Is it the hardware or the software?
Both historical traditional load balancing where the dedicate hardware application companies like FI and Citix sold expensive boxes enterprises racked in the data center. They were powerful but right and costly modern load balancing. It is the almost entirely software defined running servers in the cloud or as a server on a commonly hardware AWS Elastic load balancer.
So are there different categories in load balancer? I have heard multiple such as layer 4 and layer 3 mentioned somewhere.
Yes, and this is the distinction fundamental maps to the OSI model, which is a way describing how network communication is a layered for load balancing operates and transport layer. They are this is a TCP and UDP connects, but not actual connect of a traffic. They make a router decision based on IP, the address port and protocol. Very fast, very low overhead. They don't care. Though the inside, the pack layer 7 load balancing operation at the application layer, they can actually read a HTTP head. Uh, URL, yes, cookies, request contents. This is the lead. Let's them make the smarter routing decision. Routing request to the API video to your processing server. Routing API search to the your search server. They understand traffic.
So layer 7 is intelligent but probably more resource intensive.
So exactly that is the trade of the layer 4 faster and simple good road throughput and a non HTTP traffic layer 7 is smarter. Good micro servers A/B testing contact base routing most model web application use the layer 7. AWS has the both classic and a network load balancing. AWS has both the classic and a network load balancer works at a layer 4, while application load balancer work at a layer 7. The practice for a web API and a microservers, you are almost always want to the application load balancer.
So, is there any difference between where actually the balancing happens, like global, local, etc.?
Great point. There is the who category is called the global server load balancing GSLB. That is the load balancing at the DNS level routing user the nearest geographic region entirely. If you are Tokyo, get your routed to at the Asia data center. You are Berlin. You go Europe. West the GSLB, then within its region you have the local balancing, distributing traffic across the server. It is a specific data center. This is the two layer of 10 work together.
So, let's get into the algorithms. When a request comes in, how does the load balancer decides which server to send it to?
This is where get is the genuinely interesting. This is the server algorithm is the different trait of the simple routing robin. You have a five servers request. A request go to server 1, then 2, then 3, then 4, then 5, then back to 1. Simple routing work well servers identical and all requests.
So, bad requests aren't always the same cost, right? Some are light and some are heavy. Is that?
Exactly. That is the way routing robin broken down. The server handling heavy database quick query will be slower than one handle. The simple traffic files require your cloud and the cloud ends with the filling more work on the already by server. That is the where routing robin comes. You are assigning weight based server capacity a server with a 16 cores get a weight 4. The server with the 4 cores get is the weight 1. The powerful server get 4 times many requests better utilization.
So, bad requests aren't always the same cost, right? Some are light and some are heavy. Is that?
Exactly. That is the way routing robin broken down. The server handling heavy database quick query will be slower than one handle. The simple traffic files require your cloud and the cloud ends with the filling more work on the already by server. That is the where the routing robin comes. You are assigning weight based server capacity a server with a 16 cores get a weight 4. The server with the 4 cores get is the weight 1. The powerful server get 4 times many requests better utilization.
So, what about least connection approach?
List connection is a smaller still inside the routing the load balancer. The track how many active the connections each server currently has the routing. The next request server has the firmware open. Connection is the adapts. It's the real time actual load. The reinforcement of this is the list response time connecting activity connection count with the response time. This is server the firmware connection and the faster request time get is the next request more data better decision.
What about sickness? I've heard term sticky session. What does that mean? So, what about stickiness? I've heard term sticky session. What does that mean?
Okay, sticky session is also called a session where precedence are the where load balancer ensure the once user the assigner to the server the subsequent request to go server your stick them their reasons. This is the matter is a state. If a application the store session the locally on the server shopping carts connect the logging state and the users get a routed on a different server next time that uh, data there the user has too long again their cards empty bad experience.
Okay, so sticky session solves the problem.
They do, but introduce a new if a server user stick goes down. All this user lost their session anyway, and the mistake harder to the scale clearly because you can't just spin up a new server and have a traffic naturally distributing the better architectural solution to make the your applications stateless by the storing the session the data externally is the cases like radius the any server handle any request and you don't need a stickiness at all.
So are there any other algorithms worth knowing?
IP has is the common one. You has the client IP address and you use use the has the determine which is a server. They always go to the deterministic. The simple IP always hits the same server useful for the certain coaching. Uh, scenario randomly exactly with what is the sound like is like a pick a server randomly super super singly uh, effective with the larger server the pooling because the law are a larger number threads to distribute over the time and the more system this is the consistent hashing usually heavy distributing coaching and a database your map is the both server request on a ring structure and each request goes to the nearest server the ring the key property it is the when the server is added removed only small fractions of the request needed to be remapped a very stable distributing system.
Okay, Rohan. So this was actually incredibly clear and practical. But before we wrap up, I would like to ask you about what are the things that you would like to tell to people before you take away.
Okay. Three core takeaway. One, load balancing distributing traffic across a multiple server to the prevent any single point from the becoming it is the fundamental building the reliable scalable system without the modern internet does not modern internet does not the function two algorithm matter the round robin the simple but navigate connection smarter distributing the system scale consider the hashing the given the stable and a minimal disruption when the server pull the changes match the algorithm to the workload there's a load balancing is the just not just the edge this is a modern microserver architecture every server to server call needs to load balancing health checking and a server and a server client side discovery all so solve the different layer understanding which a layer you are opening and critical design the systems.
Perfect. So thanks, Rohan, for this master class, and it was good, great. Perfect. Rohan, thanks again for this whole podcast, and you helped a lot upon the topic load balancing. Thank you again.
Thank you Paras great conversation as always.